Tariq is throwing a tennis ball against a solid brick wall. Every single time, the ball hits the wall and bounces back. In our everyday world, the rules of physics are strict. A solid object cannot pass through a solid barrier without breaking it. But what if the ball could just pass right through, leaving the wall completely untouched? Sounds like magic, right? In physics class, Mr. Sir explains that while this is impossible for a tennis ball, it happens every day in the quantum realm. When we zoom down to the size of atoms and electrons, the universe stops playing by our normal, everyday rules. We usually imagine an electron as a tiny, hard, solid sphere, just like a microscopic tennis ball. But that is wrong. In the quantum world, particles act like waves. An electron is actually a fuzzy, smeared-out cloud of probability. This cloud represents where the electron might be. It is most likely in the center, but there is a tiny chance it is on the very edge. Now, let's throw this fuzzy quantum cloud against an impenetrable physical barrier, just like Tariq's brick wall. When the wave hits the wall, the vast majority of it bounces straight back. Normally, this means the electron is trapped. But because the electron is a smeared-out wave, the tail end of that probability actually bleeds slightly inside the barrier. Inside the solid wall, the wave dies out very quickly. Physicists call this exponential decay. But if the wall is thin enough, a tiny fraction of that wave survives and successfully leaks out the other side. Because part of its probability cloud is on the other side, there is a tiny, real chance that if we look for the electron, it will just instantly appear there. It bypassed the barrier completely. We call this quantum tunneling. It didn't break the wall. It didn't go over it. It literally just vanished from one side and manifested on the other. So why can't Tariq's tennis ball do this? Because a tennis ball is made of trillions and trillions of atoms. For the ball to tunnel through, every single atom would have to randomly successfully tunnel at the exact same moment. The odds of that happening are so small, you could throw the ball for 1 trillion years and it would still never pass through. You might think this is just a useless math trick for microscopic things. But without it, you would not be alive. Look up at the sun. Deep in its core, hydrogen protons are trying to smash together to create nuclear fusion. But protons have positive charges. Just like two magnets, they violently repel each other. This repulsion is an invisible wall. In classical physics, the sun's core actually isn't hot enough to force them through this magnetic barrier. The sun should be dark. But thanks to quantum tunneling, the protons' probability waves bleed through the barrier. They tunnel right past the repulsion and instantly fuse together. This fusion releases the immense energy that powers the sun, creating all the light and heat that keeps our planet alive. So, while your tennis ball won't ever pass through a brick wall, every ray of sunshine you feel is proof that quantum ghosts are real.